Hi, my name is Drew DuPont, one of the partners here at Uptech Studio, and we're going to do a commentary on this video on creating a counter component using the Flutter Forge library. And the perceived benefits of this is that we end up with modular, testable, UI replaceable components that we can do in complete isolation, and we're going to do it in Outside-In Development and TDD. So hopefully I'll be able to provide some context in terms of commentary to help people better understand Flutter Forge and the components and pieces of it and how we use it and how it provides those benefits. So we're just trying to create a component that has text for the count and a button. We're going to start with the outside edge because we're doing outside-in development. Here we open a test file, which is the counter widget test.dart file. And then to get rid of the mundane, we expand a snippet to create our counter widget test. And right now we're coding to hope. There is no counter widget, so we expect this test to fail because that does not exist. And of course it does. We were also informed by LSP. So now we create the component. So we create lib counter widget. Now in here, again, we have a Flutter Forge component snippet that expands. Now it drops us into the class name for the widget. So we rename it to counter widget, and then we also rename this, and now we're done with creating the basic empty component. So let's talk about what we have here because there's quite a bit going on. So Flutter Forge components are built by using this component widget class, which is just a normal Flutter widget, with some additional constraints. One of the main one is that it requires that you pass it a store, which is a concept in Flutter Forge that facilitates managing the state and the state mutation, so it's done in a unidirectional controlled fashion. To facilitate the typing of that, we also have to pass in a counter widget state, a counter widget environment, and a counter widget action. That way, the store that's behind the scenes, the typing for this store that has to be passed in can be constrained to these generic or to these concrete types that we pass in here. So you'll notice above this counter widget, we define our counter widget state class. And this is interesting. This is a class intended to just hold state, whatever that may be. Right now it's empty because we haven't gotten there yet. You'll notice that it's immutable and that it extends equatable. And that's where this get props call comes in, is that equatable allows you to define get props and then simply provide all the attributes that it needs to compare to streamline making it equatable. Counter widget environment is how we facilitate dependency injection into these components in a composable way with the Flutter Forge framework. In this particular case, we won't need to do any of that, so this is going to stay likely an empty class like this. And then we have our counter widget action, which is a base class that is defined as being abstract, which implements the reducer action protocol. This is just so we have extra type safety with our component, so that it enforces that whatever actions we can send to the store will be actions that inherit from this counter widget action. So it just gives us a little more type safety rather than having it be completely open to accept any reducer action. And then you'll notice this last piece, which is the counter reducer. The counter reducer, again, takes in the state type, the widget environment type, and the widget action type. And its job is to simply take in the current state of the world for the component and the action that the store received, and its job is to compute the new state, whatever that new state should look like, and also optionally return in a array of effects. And effects are how we do side effecting and keep that separate in Flutter Forge so that we can have pure testable functions in our reducer, and then we can have effectful code that has side effects segregated out from that. In this example, we won't get into effects, but that's why there's an empty array there. But yeah, so that is the complete concept of what a component is. It is a widget combined with a predefined reducer, combined with a set of defined actions, combined with a defined environment, combined with a defined state type. And these classes, the state, the environment, and the widget action, all create a complete formal interface with this via the store. And so the only way that things can interact with this component is through a concept of a store, unless we change the constructor of that. But the idea is that that's the only way to interface with this. And if you follow that ruling, then you will end up with a modular, testable, etc. Component. So now that we've talked about that, let's keep moving. So we just reformatted, and so now we're jumping back to the test. Now we have a component, so we should be able to run the test, see it fail, and then add the import. So we do. Now it's complaining about store because we're not passing it a store, so we have to construct a store and pass it a store. So we do a store, and right now we're just constructing that store with the counter widget state as the default, and then giving it the counter reducer that we defined, and then giving it the counter widget environment that we defined. Cool. So now our test should be passing. And it is. But our test doesn't really test much. So now we need to start adding a little more to our test. We need to evolve our test. So to evolve our test, we need to first think about what do we want to actually verify, and what is the initial state that the component should be in before we take any actions. And so that's what we're adding this expectation for right now, is we're expecting that it should start with a 0 for the count. And so we're expecting that we find exactly one widget with 0, and it fails because we're not showing that. Now in TDD practice, we're going to have to jump over and make the smallest change we can to satisfy the test. So in this case, we change this from some text to 0. It's just some hard-coded constant, and cool. We go back, magically we're passing. Sweet. Okay, cool. Now we add our second expectation, which is we want to make sure that 1 is not present at all. Right? Cool. That's good. All right, so now we get to work on the activity. What action are we going to take? So in this case, we want to tap an increment button. So we need to find increment. All right. If we run that, we should expect it to fail because we don't have an increment button yet. So we need to jump over to the component, and we need to wrap it with a column and then add a button. And we do. And here we just give it an empty closure for the action, and we just give it a text that says increment because that's what we want to call our button. And now there's something else interesting here that we should talk about though. And that is this rebuilder widget. So Flutter Forge by default does not rebuild its content when the state changes. it doesn't do this for performance reasons. Instead, it requires you to define the subset or the subset within your tree of what you want to rebuild based on the state in that store changing. And so that's what rebuilder is doing here. So rebuilder is rebuilding based on the state in this store changing. It's rebuilding this piece of the tree, but it's not rebuilding the text button, for example. So whenever the count changes or the state's going to change in this component, it's only going to rebuild this count text component or widget. It's not going to rebuild any of the other widgets. Cool. So now we jump back, run our tests. All right, our test is passing. We have an increment button, sweet. Now we're going to pump the widget so we can make sure we see any changes. Cool, we're still passing. All right, so now we're going to throw an expectation that we should find 1, right? Because we've clicked the increment button. So the result should be 1 at this point. So we should find exactly 1 of those. And if we run that, we should get a failure, right? Because it's still 0, because we have no logic in our component yet. It's literally just a hard-coded string for 0 right now. So now we jump down a level to our store tests, because we have now interfaced with the store and mutation of state is what we need to do. So we create a test, counter store test.dart, and then we create a normal, expand snippet to create our normal test structure. We define a group of counter store, and then we say, it needs to facilitate incrementing, because that's the test that we're going to do. Cool. Now, Flutter Forge provides this cool test store class, which is a special store to facilitate testing, and it allows us to construct it the same way we would construct a normal store and do behaviors the same way we would do normal behaviors. And so here we construct that, you can see. And now what we want to do is, the way that Flutter Forge works with stores is based on Redux. So actions get sent into a store, and then the store processes those using the counter reducer. So in this case, we have to create a new action. So we're going to do counter widget increment button tapped. That doesn't exist yet. We're still coding based on hope. So we see the failure. Now what we do is we take that and we go create that in our component. And so we define a new class, which is going to be this counter widget increment button tapped. And we just make sure that that extends from the counter widget action base class. And it's just an empty class. And then we go back to our test. Cool, now that thing exists. Tests are still passing, not a useful test. So now we need to look at these results. Results is an array of these types that contain the action and the paired state associated with it. Because as an action comes into the store and gets handed to the reducer computes a new value for state based upon that action. And so the results is an array of all of those over time. So in this case, we're expecting that there should only be 1. That's why we do the expectation of the length. And then here we do an expectation to say, hey, we expect that this action that we have a record of should be a counter widget increment button tapped 1. Cool. We run that test. That's true as well. Then we expect result 0. State, we're going to check that the state is the state that we want. Cool. And so here we do const counter widget state. And here we run our tests again. Things are great and passing, but that's not very interesting, and this is actually incorrect, right? Counter widget state, we need to test that the state has a count that has been incremented. So we need to deal with modifying counter widget state at this point. So we go back to our widget, we go to our counter widget state, we add an int, which is count. We add it as a required named parameter to the constructor. Cool. We add it to props so that it's included when it does equality comparisons. Cool. We go back. Now we add count to our store test constructor for the counter widget state, and we add count to our counter widget state constructor for this expectation. And we run the tests. Oh, and it fails. We got a counter widget state of 0, and we wanted a counter widget state of 1. Okay, so now we have to go back and we need to add logic to our reducer to handle the scenario of receiving a counter widget increment button tapped action and compute state appropriately for that, and then compute state for the else case, which is some action we did not recognize and we want to default to no state change. It is interesting to talk about this, I guess. So like this will get cleaned up in future versions when Dart 3 is out, because we can use sealed classes to facilitate exhaustive switch statements for this instead. So we won't have to do this type checking stuff that we're doing right now with action is a class type. Instead, we'll be able to switch on action and do exhaustive checking based on that, which will be nice. But yeah, we can see that when we do this reducer tuple, and the reducer tuple is just a type that we added to facilitate returning both state and the array of 0 or more effects, side effects that should happen as a result of that, which we'll talk about in other videos. But yeah, so this, again, this guy's job is just to compute the new state. So in this case, it's computing a new state with the previous state's count plus 1. All right. So we go back. Now all of a sudden our store test is passing. Cool. Let's jump back up to our widget test. Make sure our widget test is good. Now that we've gotten a more inner piece fixed. Oh, we have to add count here because we haven't done that. So we initialize it to 0. We run our tests again. Ooh, failing. Still are not seeing 1 in the output. Okay, so we go back to our component. Oh, we still have this hard-coded thing. So we need to now change this to reference our actual state. The way we do that is the rebuilder hands us the state variable, which contains the state object. So in this case, we had count back there. Oh, we go back, run our tests. We're still failing. And that's because we haven't actually wired that button up to trigger any actions. So we need to go back to our component and go add to that closure. We need to send an action to the store. And we do that through this proxy called viewStore that's exposed to the inside of the component. And so we do send counter widget increment button tapped. Cool. We go back to our counter widget test. We run it on success. We have it passing. Cool. So now we also want to make sure that that 0 has transitioned to a 1 and that the 0 is gone. So we make sure that we find nothing. Awesome. So now we have a fully functioning component. All right. Now it's time to jump over to Storybook. So Storybook is a nice tool that lets us build, up to this point, kind of dumb components, or components that are generally stateless or very little state. But thanks to Flutter Forge, now we can build super complex stateful components. and we can plug those into Storybook the same way we would any of the dumb components. So in this case, we're going to create a story, give it a name, description, and then we're going to have to, in the builder function, we have to return our component. In this case, we're just going to do counter widget. And we got to pass it a store, just like we did in our test. So let's create a counter store. And that's just going to be a store constructed with the counter widget state, the counter reducer, and the counter environment, the way that we did in our widget test. And then, yeah, we're going to have to constant and then fix the name of store down below. Yeah, we got to get rid of these consts from the snippet. And then change store. Now we give it the counter store. All right, now looks like we're happy. So now let's go and run our storybook, and then we can see all the work we've put in. All right, firing it up. Here we go. We got storybook running. It says to select a story. We see our counter component, and there we go. It's a little bit ugly because we didn't focus on layout or UI at all, but it's a fully functioning component. And so it's important to know and notice that we TDD'd out all the actual logic of the component using a widget test and then using a store test. And we are able to do that with Flutter Forge and do it in complete isolation. And now we've moved on to the kind of that, we've gone from the outside of the widget test down to the inside of the store test, and then kind of back up to the widget test. And now we've kind of gone back up to an even higher level, which is the kind of storybook level where we're focused on doing kind of the UI layout and design work. And then we're backed up, making sure that things stay functional by the test that we previously wrote. So in this case, we come back and we just go back here and make whatever UI changes, layout changes we want with normal Flutter widgets, right in our widget. And then we see those changes in Storybook and iterate on that like we normally would. Yeah, hopefully this intro was helpful to understanding a little bit more about Flutter Forge and the components, as well as kind of our recommended development workflow using TDD and outside-in with these components. And yeah, feel free to comment and give suggestions if you have any feedback. All right, till next time.